let the input to the system is xn equals 1/3 for n minus 1 u n minus 1, and the impulse response of the system is u n plus 3. We need to find the output of this system. The input is written or given this way. The impulse response is this. We need to find the output. What's the relation between the output and those two given signals? Hmm? What's the relationship between the yn and those two signals?
Is y of n just x of n convoluted with h of n?
Yeah, that's correct. Y of n is just the convolution between xn and hn, which can be written this way: plus infinity xk times hn minus k. So we need to find this summation. First, let's try to plot these signals just to have an idea. And again, I'll do change the time variable. Instead of n, I'll just call it k. Nothing will change. I'll just change the name of the independent variable. So this will be x of k and h of k. So to plot x of k, I'm not very good at plotting here. Yeah, it's not bad. So this is k, the time variable, and this xk. Yes. It's 1/3 to the power n minus 1, un minus 1. First, the un minus 1 is non-zero only over which n values. We know that un is
Everything greater than 1?
everything greater than 1. Yeah, that's correct. So this is just the unit step, but shifted to the right by 1. So it will start from here. Let's say this is 1. So we'll have, we'll have the first non-zero here, and this is 1, and everything else is 0. To the left, I mean. But we will see what's the value here. The value here is the 1/3 to the power 0, which is 1. So the first value here is just 1. 1. And then when n equals 2, we have 1/3. So it will be somewhere, let's say here. So this is 1/3 at 2. and then gets smaller, 1/9, and so on. And so on. It keeps getting smaller and smaller, so it approaches 0 at infinity. So this is xk. We need to plot hk as well. Okay. hk is un plus 3. So this time the unit step function is shifted to the right, to the left, sorry, to the left. So we start from n equals -3. So -1, -2, here's -3. And then before this is all zeros. And after that, we have ones. So this hk. So in order to do the convolution, as we said before in the review, we first need to flip. We first flip the impulse response or do a time reversal and then start shifting by n to do the convolution graphically. But let's first do it without plotting this every step, and then we can do it graphically. So if we multiply those two signals together, so we have xk and hn minus k. Let's just plot the hn minus k to see what are the limits of the summation. So first, I'll just do a time reversal. So h minus k will be we'll start from 3. And it's the scales is very bad. So, but and then when k is larger than 3, it will be all zeros. Okay, we just did the time reversal, and then I'll do a time shifting by n. So h will be h n minus k. I'll do a time shifting by n. Let's say n is positive, or let's make it negative. The point is to check if n is larger or smaller than 3, to know if we have shifted it so much to the left, and then this move from 1 to 0 is at k less than 0 or greater than 0. So let's say n is less than -3. If n is less than -3, hn minus k will look something like this. It's a right? In this specific case, n is -4. So here is -1, -2. Or it's -5. And 1, 2, 3, 5. Yes. This is not 0 here. So we shifted the impulse response by 5, the left, and it will look like this. Now, if I multiply xk by hn minus k, what we'll get? This is hn minus k. And this is k. This xk. If we multiply xk by hn minus k, what will be the output? Hmm? Um, is what I'm explaining clear? Are you following with me?
Would it be 0?
Yeah, it should be 0. That's correct, because we don't have any overlapping non-zero values. Like all the overlapping from k equals 0 and beyond it to be non-zero. Xk will be non-zero, but hn minus k will be zeros. So if we multiply them, they will be 0. And the same on the other side, xk is 0, hn minus k is non-zero. But if we multiply them, the result will be 0. So from this, we can say directly y -5 is 0. Like we found the value of y at only this point, right? This is just to have some intuition, but we need to do it without the figures. So hn minus k, let me write it here again. Y n equals summation from -infinity to +infinity xk hn minus k. Let's substitute xk and hn minus k. Xk was 1/3 for k minus 1, because we have changed the independent variable from n to k. So this is k minus 1. Let me correct it. One-third to the power n minus 1 times u n minus 1, or uk minus 1 in this case. And then hn minus k will be u, and then we replace n by n minus k times u n minus k plus 3, right? Plus 3. Now we have those two u's. The first u, or the first unit step, is non-zero only when
Just give me a sec. I'm still in. Oh, sorry.
sorry, what's that?
Oh, sorry about that. I was in a phone call. My bad.
Oh, okay, no worries. Are you with us now? Okay, so let me split those two parts. We'll discuss them each one individually. So the first one is non-zero, and it will be 1 only when k minus 1 is larger than or equal 0. Then k should be larger than or equal 1. We have here the first condition. Now from the second part, this will be 1 when n minus k plus 3 is larger than or equal 0. This will give us k is less than or equal n plus 3.
Is that the way to like determine the bounds or whatever?
Sorry?
Is that like the way to determine the bounds for the
Exactly.
summation?
Yeah, exactly. And we
Okay.
usually do the same or similar things for the continuous case when it's an integration. We need to find those functions. Those function will give us the bounds for the summation, and then they will just disappear because their value will be 1. Otherwise, they will make the summation 0. So we are interested only in those two in this region between 1 and n minus 3, n plus 3, sorry. So k should be 1, 2 until n plus 3. But here n should be, we have another condition on n here, right? Because if n is less than minus 3, it will make k less than 0, right? And this contradicts with this, or will violate this bound, which says that k should be larger than 1. So we have this condition as well. But for now, since the summation is over k, those only will affect the bounds of the summation. So the summation will be from k equals 1 to n plus 3. N plus 3, and those will be 1, so they will disappear. The remaining term is just 1/3 k minus 1. Okay, k minus 1. Yeah, and the summation is from 1 to n plus 3 to satisfy both of those two constraints or limits. K larger than 1, less than n plus 3. less than minus 3, n is less than minus 3. Actually, it should be even, we can make it stricter. Minus 2. Because, let me remove the equality as well. Less than minus 2. Because if n is less than minus 2, this will make k less than 1. And this will violate this bound, this limit. Because k should be larger than or equal 1. So n cannot be less than 2. So, so let me put it here. What happened? Just 1 second, sorry for that. I hope it's saved. Yeah, it's working now. So n should not be less than minus 2. Should be, in order to keep this limit satisfied, n should be larger than or equal minus 2. Okay. So in order to solve this summation or to find the value of this summation, we need to consider some ranges for n. If n, when n is larger than or equal minus 2, we have if larger than minus 2, then yn will be summation k 1 n plus 3 which is this geometric series. What's the value of this summation?
I don't remember the formula, but isn't it like 1 over r minus 1 or something? I don't remember the geometric series sum formula.
Yeah, the general formula is when the summation is from, let's say, n1 to n2 of r to the power k, this k equals, this will be r to the power n1 plus r to the power n1 n2 plus 1 divided by r plus 1, right? Yeah, let me double check. Yeah, this is a minus. This is a minus. I think you will be given those formulas in the cheat sheet for the exam. So, but yeah, this is the general formula for the geometric series. But here we have k minus 1. So we need to make it k. So the summation will be k equals 1 to n plus 3. In order to get rid of this minus 1, we can write 1 over 3 power minus 1 times 1 over 3 over k. And this will be just 3. So equals 3 times the summation. K equals 1 to n plus 3. 1/3 to the power k, which is 3 times the first one, which is r to the power n1. So it's 1/3 minus 1/3 power n plus 4 divided by third minus 1, right? Yeah, that's correct. We can simplify this a little bit. This will be 2/3 3 here plus 3 times this is 2/3, so leave the 2 here, and this will be 1 minus 3 times 1/3 n plus 4. That's correct, right? 1/3 minus 1 is minus 2/3. So we have a minus here. Is that correct? Let me see. Um, one five. Oh, I think n1 n2 plus 1, then 1 minus r. Yeah, this is a this is 1 minus r. It's 1 minus r. So the issue, the mistake that I have made here is this should be 1 minus 1/3. 1 minus 1/3, so we'll have 3 outside. 1 minus 1/3 is 2/3, so the 2 remains here, and we multiply by 3 this side, so it will be times 1 minus 3 times 1/3 to the power n plus 4. And this can be written as 3 divided by 2, 1 minus 3 times. If we take one term out of this, it will be 1/3 times 1/3 to the power n plus 3. And those will cancel. And this will be the final over 2, 1 minus 1/3 to the power n plus 3. So this is yn, but only when n is, as we said, only when n is larger than or equal minus 2. Larger than or equal minus 2. So this is the first part of yn. Now, when n is less than minus 2, as we have seen, should be minus 2. When n is less than minus 2, we don't have overlap. We don't have overlap, and then yn will be 0 over this interval. And then it's done, because we have covered the whole range of n. When n is larger than minus 2, larger than or equal minus 2, and then when it's less than minus 2. So we have covered all the range of values for n, and now we have the yn completely defined. So we can write it finally this way. Yn is 0 when n is less than minus 2, and it's 3 divided by 2 times 1 minus 1/3 the power n plus 3 when n is larger than or equal minus 2. I don't know. Okay, you got it. This yn has 0 values before minus 2, and then this function after n equals or greater than minus 2. And you can actually verify this by doing this similar steps on the graphical, using the graphical method. You start shifting n minus k to the right and multiplying with xk and doing the summation over the whole k values, and you'll get the same result. I think I'll stop here because we are already over